Good afternoon. I'm John Keever at TellIt IoT Platforms, and we're going to take the next 30 to 40 minutes and spend some time with you talking about the important shifts of strategic thinking, partnerships, and flexibility when you're putting together IoT solutions. So let me get the slides queued, and we'll be taking it from there. Hopefully everyone can see my slide deck now. So again, as I said, we'll be talking about partnerships, flexibility, and strategic thinking as we implement IoT solutions. As I said a moment ago, I'm John Keever, CTO and co-founder of TellIt IoT Platforms. I've been part of TellIt now since 2013, and I'm glad to have the chance to spend some time with you this afternoon. I don't know how many of you are familiar with TellIt. If you're an Intel customer, you very well have worked with us already. Clearly, we've been in the business pretty much since the inception of IoT, machine-to-machine and IoT, in excess of 15 years at this point. We have over 7,000 customers worldwide, over 1,000 employees. And if you look at our cumulative man-years in R&D, it's probably in excess of 2,500. We do provide a collection, an ecosystem component set, everything from IoT modules to actually cellular eyes or Wi-Fi eyes or Bluetooth eyes, your device that you may be working on, all the way to TellIt services to support with that cloud connection, your actual media connection, as well as the cloud platform to support the actual data management, device management activities that you may have. And probably most important with that expertise comes years of knowledge and know-how to help you be aggressive and get to your end goal quicker. As you put that solution together. TellIt is both a customer and a supplier of Intel, so we enjoy that relationship and greatly appreciate the chance to participate in today's session. If anyone tells you that IoT is something that you do, you get started, you complete the project and it's done, then they're not telling you the truth. IoT is a journey. Like most large-scale IT solutions that are put in place, you start it, you develop it, it takes on a life of its own, and it has to be supported and maintained for the life of its functional value. So as far as IoT goes, when you're going about putting this together, you probably want to choose your partners wisely. I would say that there's probably no single company that can provide all of the componentry, services, and technology required to do a complete end-to-end IoT solution, whether it's sensory domain, connectivity domain, processor domain, software domain, and cloud domain. Lots of different components need to come together to complete that IoT solution. If you take a look at the solutions, many times people take off down the road and they say, well, I basically have an endpoint and I have a cloud and I have IT, so I should be able to connect the dots. And you definitely can go about doing that. You can connect the different components as you need to, whether it's a modular connection, to a back-end dashboard, whether it's a gateway connection to a back-end enterprise application, or maybe it's just a telematics connection feeding a big data system for offline analysis in the future. At the end of the day, though, when you start putting those solutions together, there's a number of components that come into play. You have to worry about connectivity. How are you going to connect it, and how are you going to manage it once it's connected? Very important that you do this because things tend to go bump in the night and you need to be able to recover when things go offline. Device management, another critical component that oftentimes gets overlooked when you're laying out that initial system. How do you take care of those endpoint devices? How do you update them? And when they do go offline, how do you get them back online again? So device management being another critical component of that overall solution. Administration and security, I think it goes without saying in today's world, anywhere at connectivity points, whether it's within a building, across the internet, or at a satellite level, security is critical, and it has to be built from the inside out. It can't be something added after the fact. So very important things to consider as you're putting together a solution is how do you administer it and how do you secure it. And of course, at the end of the day, IoT can often be called a means to an end. At the end of the day, it's there to feed your application solutions on the back end that you run the company with or make decisions from. So it's very important that the system be integratable with easy to use APIs and flexibility. So that's what we're going to do over the next period of time, is we're going to take a bit of time and focus on each one of these in depth. So let's get started with a little bit of perspective. If you take a look at what an actual IoT platform does, it helps to normalize all those different point-to-point connections. It helps to give you the flexibility to change things out on one end of the solution without upsetting things on the other end of the solution. And most important, it provides that security and management capability that's so badly needed to complete and deliver that end-to-end solution. So again, as we take off on our journey for this presentation, we have to choose our partners wisely. Now, some people consider the possibility of going it alone. We'll just go ahead and build this. We've got IT resources. They have time on their hands versus saying, okay, I know what I need to do. I know the business that I'm in, and here's the tool set that I need to get to that endpoint, and making maybe a more informed buy decision. I think most of the times people who decide they want to go off and build a solution on their own don't really, appreciate the complexities of what they're going to be getting into. You can see here in this one scenario that a customer had sized for their efforts. They had in excess of 20,000 man-hours of customized development between device management and connectivity management alone. So these are the types of things you want to think about as you're making that early, upfront decision. Am I going to make or am I going to buy? More often than not, it simply makes more sense to purchase a platform and work from there. It's not as though any of us take off now to build our own operating systems, our own, word processing tools. We use tried and true technology from vendors who have, stayed the course, delivered on that for years. So let's take a look, as I said earlier, on a bit of a deep dive into each one. And hopefully, as we go through them, we'll be able to identify some thought processes, maybe turn on some light bulbs about, specific things that are of interest to you in your journey, wherever it might be into the world of IoT. So let's get started, here by thinking about connectivity management. When we think of connectivity management, it's definitely a very challenging and flexible front. Not only is the raw technology itself somewhat challenging, the number of technologies available to you can be quite daunting. And the next exciting thing is they're continually changing. None of this technology stays the same for very long. As new releases of standards come out, new carrier frequencies and functionalities and low power options and all are presented. And so you continue to move forward with features that benefit IoT, but at the same time, cause challenges as well. And it's not just, the statement of what am I doing in the near field? Am I worrying about, some type of, short range connection to get sensory data onto a gateway? Am I then going to do some type of, backhaul over a low power wide area type of network infrastructure? Or am I going to go straight to cellular infrastructure? And if I'm going straight to a cellular infrastructure, what cellular infrastructure works, for me? And again, all of these technologies need to be brought together and dealt with as you're starting to formulate the solution that you're working on for IoT. And another critical thing I just thought about as well is the issue of region. As ever-changing. 2G is a perfectly viable functionality in Europe possibility, but would be the last thing you'd probably want to consider in North America at this point. Moving forward beyond 3G into LTE very aggressively, and then the many derivatives of LTE. So again, not only is it the technology that you're selecting, you also have to take into account what technologies are supported in what regions of the world as well. So let's take a look at this thing. Okay, obviously connectivity providers each provide their technology offerings, their networks, their particular, carrier technologies, the partners that they make available to you, and the policies, that they support and deploy as part of their solution. You have to consider each of these, and many times around the world, you have to consider multiple, ways. That's one of the things that we work to do, is to try to normalize that for our customers. So our customer can have a unified data plan globally and have technology that supports them as they move from location to location. A solution or a machine that's IoT connected may be built in one country and delivered for implementation and deployment in another. You have to think up front about how that connectivity is going to be provided and how the costing is going to be dealt with. Obviously, you couldn't afford to have, solutions roaming in foreign countries simply because you didn't think about that up front. You have to take these kind of things into account as you're putting that solution together. Also, it's not enough that you get the connection done. You have to worry about how are you actually going to charge for this? How are you going to monetize that? Once the system is provisioned, in a secure manner and reliable, integrity manner, then you have to worry about the life cycle of the solution. As it starts to age and other technologies start to come into play, how can we make the changes and move forward without disrupting the overall functionality of the solution? In the world of IoT, there's really no option for rip and replace. Once you have thousands and thousands of device endpoints in play collecting valuable data, you can't simply turn it off one day, make changes, and turn it back on in a few months. That has to be done in a very managed and controlled environment. So working with partners that have these kinds of scenarios and systems for support is critical. So a good partner, a good platform would typically provide a lot of technology to help you with your connectivity. Dashboards that help you consolidate the information so you can have visibility and control over what's going on with the connections. If something goes offline, how do we go about using a lower airplane to get that back online? And how can you optimize the behavior of your connections to minimize your data costs? The ability to associate notifications and triggers and alerts with each one of these functions is very important as well. And as I mentioned earlier, the capability to have billing rules and definitions. As the data starts to traverse the cellular network and the wired network, whatever your mechanism may be, the ability to meter that and know how much information or how many messages are flowing to use for possibly either backend analytics or customer billing. So all of these things to be part and parcel of a well thought out solution platform. Next thing we want to talk about is device management. And this is one area from our expertise that very often gets overlooked in the rush to get something working. As long as you're going down the garden path, it's pretty easy to connect the dots to get the data to flow from an endpoint into some type of backend application. And it's interesting, if you look at the software platform that we have here at TellIt, I would say in excess of 80% of that code is really handling what goes on when something doesn't work correctly. It's not the garden path that's the challenge. It's how things get handled when things don't work as you expect them to do. Device management is a critical part of this kind of functionality, mainly because as the devices that you implement multiply, the problems that you have multiply as well, and not necessarily in a linear manner, mainly because you have a multitude of different things to deal with each one of those device connections. You have not only your firmware to worry about, or my firmware's all at the same level, and most likely they aren't as things roll out. In a large-scale solution, you'll have different versions of firmware. You may have an attempt or a need to try to keep those normalized from a maintenance and cost perspective. Security, have I worried about buttoning down or buttoning up the edge point as closed as I can so that I have the level of security that I need? Do I know that that device endpoint has a unique identifier and is the device endpoint that I think it is? And of course, the whole reason we're deploying the IoT solution is for the functionality that it needs to deliver. So providing some type of sensing, some type of actuation, or a combination of both. So these are the types of things we need to think of from a maintenance dimension as we're putting that over together. Now, one of the main things you want to look at is over-the-air, updates and management. The capability to have that support there when it's needed and to be able to work with any number of devices. It's critical to understand that devices come in all shapes and sizes. They may be custom boards, something the size of a locket that has some type of communications mechanism that still has sensory capability on board, all the way up to something as large as an industrial gateway, where you may have many channels of communications downstream and then several channels of communications upstream. So all of these types of things need to be taken into account, and the capability to remotely reach out and connect to that device and update the firmware, update the applications on board, or make configuration changes are critical to that. And then, of course, the need to do that across boundaries in a global manner goes without saying. Most of the times as you roll out an IoT solution, the endpoints don't stay there close to you. They tend to travel. And of course, that brings on, one of the scariest things there are in IoT deployments, which are truck rolls. The last thing that you want to do is to have to manually, have a technician get in the truck, drive to a location, and physically, reconfigure, firmware update, or change out a piece of hardware. It's very, very expensive and something that really affects you in a multitude of dimensions, not only from a standpoint of the raw cost, but the actual downtime and the customer satisfaction associated with it. Many times, customers look at truck rolls as not only a killer to their business model, but they can actually be the death knell of their business in the event that the cost was so prohibitive that it would keep the solution from being viable in the IoT domain. So having said that, I'm not trying to put fear into you. I'm just trying to make you think about it. If you're putting in a solution that's based upon, many endpoint devices that are remotely located and controlled not by you, but by the customer at the endpoints, you want to make sure that you have effective over-the-air capabilities to support those endpoint devices with your device management system. And as you look at the device management system, you need to think of the types of things that go on, and this is also depending on the complexity of the solution that you're providing, exactly the capabilities that you'll need. Do you need remote provisioning and authentication? I would think in most cases this is a yes. Device configuration, how configurable is that device? Are there scale factors? Are there frequency factors that could possibly need to be modified on the fly? So in those situations, you have to consider that as well. Monitoring diagnostics kind of goes without saying. The capability to know when a device is connected, to know when a device is sending viable data, is kind of a baseline requirement for almost any remote connected device. And then finally, software maintenance and update, the ability to do that firmware update over the air, that application update over the air. Making sure that all of these features are there for you is the sign of a well-designed overall platform. So what you want to watch out for is for platforms that have fragile or limited device management. If there is a platform that's primarily focused on data movement alone, you probably want to associate or use additional components to provide that capability. You need to focus on what kind of outcomes you need, for an endpoint, kind of an acceptance level, so you know when you need to deploy the remote maintenance and capability of the system. And then you need to make sure that you don't slow things down getting to market. You want to be as aggressive as possible. So you don't want to have to take the time to build device management into your solution as you're creating it. You need to identify a partner with a platform that has those functions to start with and build on that. So now let's talk about application integration. As I said earlier, one of the mainstays of IoT is the reality that it is a means to an end. The need to connect the devices, connect the sensors, the actuators, whatever function they may provide at the endpoint is all about more effectively running the business. So at the end of the day, we know application integration is a must. The capability to be able to cleanly integrate into either a management system or a reporting system, some kind of big data analytics system is part and parcel of any IoT solution. So let's talk about that a little bit. If you take a look at the types of things that people do, they start out at a minimal, functional level with dashboarding. I want to see a nice graphical dashboard of where my devices are. I want to know what's connected. I want to know, when it last reported in. I want to know how much data it's moved. I want to see the value of the data, and I want to be able to trend it. I want to know if it's going out of band, all the kind of basic dashboardings that people do. And they want to do that across a large cross-section of mobile devices and web-based devices. So there's no one-size-fits-all in the world of IoT, and there's no one-size-fits-all in the world of the types of devices people use. But at the end of the day, as IoT matures, the need for big data capability, cognitive analytics, things, high-end functional analytics provided by companies like Google, IBM, and SAP come into play. And the ability for a platform to cleanly plug and play with the type of analytics that's needed to achieve your goals is very important. There's no one answer for analytics. And if you take a look at something that you're doing with IoT, is it goes back to the fundamental statement that knowledge is power. And in the world of industrial IoT, for example, you may have some kind of machining center on the shop floor that you're interested in machine health, about diagnostics, being able to do some form of preventative maintenance, and hopefully going in the future predictive maintenance, as well as replacement of consumables. That's all kind of the basic information that you're going to get by instrumenting that machine, looking at the different controls and data available, and then starting to apply some basic analytics. The exciting thing is there's a synergy and a benefit. It's almost a multiplier in the world of IoT, where there's other values that you get out of that. You start to see employee behavior by shifts, by times of day, by training levels. Why are some employees or some teams more efficient than others? Are they possibly not operating the machine correctly on third shift because they've never received the proper training that they needed? Those are the kind of things that you get in addition to what's going on with the machine that we found customers to greatly value. As a matter of fact, I don't think we put in a single IoT solution over the last, I should say connected solution system in the last 10 plus years, where many, many other features and additions were added after the initial project because people saw the value of finally being able to get data from that endpoint. Very rarely, if ever, does anything, decrease in scope, and almost always increases in scope. So the ability to have that comprehensive and agnostic data delivery is critical. The ability to have the to support robust APIs is important. So you're not doing one-to-one coding with long development cycles. You're effectively able to not only bridge the gap between an endpoint device and your dashboard or your analytics, but also other cloud platforms, the capability to bridge into current, on-premise systems. These are all the types of things that you need to do to support that integration effectively. So you want to choose your partners wisely. A solution enabler is not a data scientist. I always say that data science is in itself a science. It's not simply that one size fits all where you can say, okay, I've got some basic analytics, so I have big data analytics. You really need a different system typically to focus on the depth and the complexity that comes with that. So the capability to have a well-defined, highly integratable cloud platform is a critical part of that, so you can get the data where it needs to go, when it needs to go, instead of keeping it kind of bound within and trying to do analytics for yourself, what we would call a closed loop solution provider. So a little bit of overview there, and the importance of their flexible integration is critical. Now, for our next set of communicator and discussion here, let's think about security. We're currently on our third generation of IoT platforms since 2007 timeframe, largely because of scalability and security are the two single things that have driven us the most in terms of enhancing the platform. And security continues to become further enhanced, continues to change. But I think, as I mentioned earlier in the presentation, that it's something we all agree has to be built from the inside out to drive the solutions that we need. The reality of any type of IoT deployments you're going to have is you're going to have thousands of unique devices, you're going to have thousands of unique users and use cases, and you're going to be dealing with a platform or a couple of platforms that have to address them all and deal with the vulnerabilities of all of them. You have people, you have machines, you have networks, and you have data. It's just a recipe for challenges from a security perspective. So we need to focus on how do we pull those components together. One of the things we focused on is doing this at multiple levels, at the thing or the endpoint level, whether your thing happens to be a pet tracking device or a complicated piece of machinery on a shop floor, the capability to have that intelligence there. It may be something as simple as AT commands where you're working with a cellular device or a Wi-Fi device to onboard and connect into the cloud. It may be as complicated as a edge level gateway with a good bit of streaming analytics that ranges from all of those domains, but at the same time has to have certain level of security built into it. At the networking level, the capability to tailor your networking configuration, from a perspective of recovery, redundancy, being able to have the types of configurations and connectivity you need is critical. And this runs the gamut from basic wired solutions to hybrid solutions, even to solutions that have not only, maybe wireless sensors and wireless connectivity by way of cellular, but it may turn into satellite connections as well, with the capability to implicitly fail over between them to keep the data movement going. And then finally, your cloud level, the capability to make sure that the people who have access to the data are the people who need to have access to the data. And that is true basically from not only a person, but a machine as well. For example, the capability at a thing level to know that a device has a unique identity. It's not easily spoofed, or it's almost impossible to do it because of the capability to have immutable, trust zone type securities at the edge where those devices connect. They are, identified properly and dynamically, taken care of from a certificate and security perspective. The capability then to give that device access to data, access to business, functionality and operations, it makes a world of difference. You don't feel like you're open and exposed in any way. So these are the types of things that you need to think about at the edge from a security perspective. What type of security is built in? Even down, as I said earlier, to the AT commands. How are those AT commands implemented? What's going on the back end of those AT commands? And is there any way for those to provide a breach or an exposure as well? So you need to think about all of these technologies as you move into it. If you take a look at the other end of the spectrum, at the cloud, then you get into the whole challenge of how are we administrating a user? How does a user or a thing have access to data and the operations? The capability to have very advanced authentication and the capability to validate that the person sitting at the end of that keyboard is the person you think it is, or the end of that mobile device. So these are the types of things that have to be put into place at the cloud level. It can't be just at one point in the overall solution. The capability to provide the expertise at both ends of that spectrum is critical. The ability to support ISO security standards, being able to participate in the standards bodies to enhance the platform and the technology associated with it as the standards mature as well. These are all critical things to consider as you're, working with a partner to put that solution together. Moving into the future. So you want to think about security. It's almost like I want to say security first as a thing to consider. So as you take a look at where we're going with this, clearly we've got go it alone or go it in a fast track mode with a partner of choice that has the expertise, or most likely a collection of partners. So let's take a look at how those types of things come together to drive a solution in your domain. So we can take a look at that. from the standpoint of solution architectures and alliances, world-leading partners in the space with trusted and proven partnership. What you want to think about is how long have these particular suppliers been in the game. I know that we hear, often now in the space that there's an excess of 300. I think some people are even saying 400 different cloud platforms out there. But if you start digging into it and looking at the ones that have, delivered and have the maturity and the scalability and the redundancy that's needed for a mature platform, that number, drops considerably pretty quickly. The capability to have a robust and tested infrastructure. It's not just the front end that matters. You have to dig underneath that cover, that thin veil of the UI, and get into how is the platform put together? Is it a service bus model? Is it some monolithic data model? You want to look into that and understand the framework from the inside out to help you better understand the capability for scalability, and for security, for integratability. All of these things are important as you start to put together solutions in the IoT domain. And some of the partners, again, you need to look at it from an end-to-end perspective. In the context of Intel, there's a number of first-class partners that obviously have household names that are tried and true in the business that have been there delivering solutions for years. And the capability to integrate with those platforms from the edge up is very important. And most of these vendors offer a pretty broad collection of devices, with and without different types of wireless connection, both upstream and downstream, as well as hardened operating system platforms. Reference Wind River here as well, where you've got the capability to have a high integrity operating system platform on board, and then have that be part of the overall end-to-end security model as you deploy that solution platform. So you need to think about it from that perspective as well as you build out your solution. Here we have, solution, overview, I guess, relative to Wind River and the device cloud and how that comes together from both remote monitoring out at the edge, security over the air, the firmware and over the air updates, the abilities to support those alerts and rules, update campaigns, and data management and monitoring. These are all critical features of a successful end-to-end solution deployment. And here, choosing a partner wisely as you go to put that solution in place. And again, it does leverage technology and capability from Telit. So we look forward to, obviously supporting you and having the capability to work with you on a deployment of this nature. Similarly, Intel has invested a good bit of time on the IoT front. This isn't something that they have casually gotten into. Those of you that are part and parcel of the Intel family that have seen the Intel industrial IoT framework mature over the last several years have seen the investment that they've put into it. The entire, joint architecture for the industrial IoT is one good example of that, where it's pretty much an end-to-end ecosystem of not only products identified, but the partners identified to pull that together and to pull that solution together in the context of a specific manufacturing solution. You may be focused on an HVAC solution. You may be focused on monitoring a machine tool and getting critical information off of a machine tool. Maybe you're looking at some kind of defect recording on the plant floor. The capability to have a partner ecosystem that brings to bear a collection of products and the expertise to help you connect those dots is critical. So if you're interested in this, you probably want to also pursue a little bit more information on the behalf of Intel's IoT solution as well at intel.com/IoT, helping again to simplify the IoT as well. On the other end of the spectrum, once you have that floor level, system and deployment put in place, you have the native protocols connected at the machine level into the gateways. You have that information being, forwarded then upstream into a cloud platform or an on-premise data repository. Then you have the next step is, in order to get business value out of it, what are you going to do with it? So then you typically want to turn to some type of formalized analytics system, whether it might be, SAP HANA for predictive analytics, where you're looking at a solution there. Maybe it's Google Cloud Platform with the big table where you're doing some type of analytics of your own across a large number of endpoints. For relatively, advanced numeric analytics, or you may be doing something as advanced as cognitive, analytics and an IBM Watson solution, where you're getting the information together and letting the system come back and tell you patterns and correlations that the system is sensing. So it really depends on the end goal that you have for what you're collecting in IoT as to what you want to apply and who you want to partner with at the cloud level to provide your solution. In this scenario here, you can see we're referencing SAP Leonardo and what they're bringing to bear and leveraging, again, TellIt technology to help provide the connections, the device movement, and device management in the overall solution. But the capability to work here and provide an end-to-end ecosystem from a source point all the way into SAP HANA and do that effectively on a platform that's been validated and deployed to reach the kinds and scale to the kind of solution numbers that are required for customers taking advantage of the SAP Leonardo platform suite. So we spent a little bit of time, a little over, going on 40 minutes of time that we spent relative to IoT being a journey. And the fact that it's your opportunity to get started and move in that direction. I would say there aren't too many companies in business today that don't have some type of IoT effort in place, whether it's a small scale proof of concept or a large scale rollout, ranging everywhere from data collection and control and actuation all the way down to something as basic as telematics and simply tracking equipment and what's going on with those endpoint devices. The main thing is addressing the business challenge of either, increasing, your revenues, making a profit, reducing your costs, or being compliant with the types of solution domain requirements you have in your particular line of business. But the thought I would want to leave you with more than anything is it is going to be a journey. It's not something you're going to start and then stop, 3, 6, 12 months later. It's going to take on a life of its own and extend into the future. So as you do that, to get started, you probably want to choose your partners wisely. There's an old Indian saying that if you want to go fast, you go alone, but if you want to go far, you go together. And the same concept applies in the world of IoT as you get started into the future with that journey. From a standpoint of TellIt, we're here to help. We have obviously many years of expertise in deploying solutions at every level, from the device and cellular module level all the way to the cloud platform and the analytics speed level. So we're here to help. We can help assess your needs, map out a migration plan for you to work with, and help you achieve a proof of concept with some well-defined acceptance criteria to make it a success. Also, for those of you that are wanting to learn more about basic IoT technology and all of the complexities and solutions that come with it, the tool sets that are available to help manage it and make it a reality. We offer our IoT University here at our Boca Raton, Florida facility. We have classes charted out in December, January, and into March of next year. Many people enjoy visiting the Florida in the winter time, so it's probably a valid time of year to be advertising this for those of our friends in Canada in the Northeast. And of course, the capability to reach out and ask us questions and work with us, to get started. So feel free to do that. We've provided email addresses here for you to make contact as well. And I think at this point, I'm supposed to open up just for questions. Is that right? Do I need to stop the slide?
Yeah.
Okay, so I can do that as well. Let's see here. So should I not share? Just go back to the camera.
Yeah.
So So there are some questions. I guess I have to look off to the side. The screen's actually another location for me to look at. So can you create a private closed internal network of things that is secure and data is not shared using Telit products and services? Okay, it's a pretty good, basic question. The model that we have in our particular infrastructure is a multi-tenant model, which is nothing new. It's effectively what it says. As a tenant within a building, you have your space and it's yours and it's protected for you, although you share resources, electricity, plumbing, things of that nature within the building. The model is the same, and within the TellIt platform infrastructure, we have the concept of organizations, and each organization is a container for your specific collection of things. We call it the thing manager that you have within that, and then each one of those things can have an associated data model associated with it, and then that data is persisted within the platform. If you're working in a data at rest model, where that data is captured and held in the cloud for later viewing, analytics, etc., that data is persisted and segmented. There is no way to get to that data between organization A and organization B as data is shipped into them. It's highly segmented from a standpoint of data management. Okay, next question. Can you share an industrial IoT use case that you have worked on, preferably in manufacturing? Okay, that's a good one. I've been in this domain 30 years, 20 years of that leading up to the founding creation of ILS as IBM. And then for the last, 17 years as we've deployed solutions more, not only from an industrial IoT manner, but, basic manufacturing as well. Clearly, industrial IoT, leads itself, very well to the plant floor. The first challenge there is always connecting to the source points of your data and doing it in an effective manner, and then getting that information to the right person at the right time to make the proper decision that they need to help optimize production, reduce waste, scrap, etc. As far as actual, manufacturing applications, they run the gamut. I would say one of the most common signatures would be something we call as-built data collection. Very common in the automotive domain as the carriers, whether you're on a frame carrier or you're on a tow, a chain along the assembly line, then data is collected at each point that those devices stop. They may work in a synchronous manner, they may work in an asynchronous manner, whereas work gets done, they can forward and sit in queue. But the capability there is to tap into the controllers, the industrial controllers, logic controllers, the vision systems, the nut runner systems if you're doing assembly of bolted things, engines, transmissions, etc. And then, of course, all of the other ancillary peripherals. And that's, I would say, one of our strongest suits with our history is the capability to support those connections into all those different types of devices, usually speak the native protocol of the device, work in an unsolicited manner, where as the data changes, the data is fed into the local workstation, gateway, whatever you may want to call the device there, or a centralized system, in some cases where they will multiplex data back to a centralized server. But then to receive that and then take event-oriented actions on it. That really is, I think, the important thing for a manufacturing solution, whether it happens to be an automotive, an assembly, or maybe some type of wastewater or water purification type of processing. Industrial IoT types of applications is to have an event-driven model, okay, where each event indicates some form of unit of work, where you're going to, as a result of some form of data change, do a collection of activities to either, reduce data, combine data, create derivative data, and then move that upstream into either a database system, into your ERP or MES system, depending on the scale of the control that you're doing within the factory. And that's usually where the device-wise suite of products within industrial IoT will work, as we will sit between that control level of the logic controllers and the physical, sensorial and actuation devices, move that then back into maybe a database for quality, feed an MES system for, work in the tail, and then of course interact with the ERP system to let it know what is complete, what isn't complete, what's in test, things of the. So that's, I didn't directly name a customer, but the basic concept of as-built data collection, managed as it moves, as it goes into rework. Those are the types of things that we do. That's probably a $10 answer to a $2 question, but it's a reality. Are you seeing any, let's say, what's the next one? Are you seeing any industry standards in the scalability space? This is a little bit of one that's a little bit off to the side of my focus, but scalability has been one of the biggest things that we've had to watch in terms of design, particular, solution set within the Telit. To date, we've been working, primarily with models, coming from the people who do it best at large scale, more social, media types of venues where they've had to scale to, millions and multi-millions upon millions of users to look at how we scale, our particular messaging and our data frameworks. To date, I personally haven't been engaged with a standard oriented to scalability, but it would be an interesting thing to look into from either, the standpoint of 1M to M, or, the TIA standards, and see, what might be there from a standpoint of IoT scale. This generic, system scalability and a data, from a data or persistence statement, or a messaging and connectivity statement, but more of a multi-dimensional scalability statement in the standpoint of a standard. I personally haven't, seen one presented, but I'm all ears if someone's presenting one. Any other questions? I'm sorry, I have to turn to the side. I'm just checking to see if anything else has popped up on the screen. Okay. Well, it appears that there's no additional questions coming in, so we'll give you about 14 minutes of your day back and let you get ready for the next session here as part of the Global IoT Dev Fest. So thank you so much for attending our session today. Hopefully you found it informative and a little bit thought-provoking, and we look forward to meeting with you again in the near future. Bye.